All right, let's get started. Thank you all. Today's topic is going to be Controllers 101. We have, we'll say, attempted to do controls training in the past. Some of it's been good, some of it's been bad. We're going to walk through some things, but we also got some live demos today, which will be something new. Hopefully you all find that useful. Today helping me with today's presentation will be Vince Fagerstrom. Most of you know him. If you don't, he's our CT product sales, market sales engineer. I know those things are evolving. He works with James Crooker, who's also joining us. Vince and I today will be, to start with, covering, we did a series last year and the year before, Programming 101, 201. Some of you may be aware of that. If you're not, I'm going to walk through what's available, what it is. More importantly, because it's going to touch on a lot of the things that Vince is going to talk about. The big presentation today will be selecting a controller, which Vince is going to walk through. Many of you have had questions, even to myself, about am I selecting the right controller? What are the options, the values? What am I looking for, and how to do that? So Vince is going to walk us through that. And after that, we've got some pre-recorded demo walkthroughs of the 4040, 4081, 6050, and 6040 overtemp that we're going to walk through and kind of point to. And so it doesn't substitute for the real thing. I know that, but it will give everybody some exposure to these so you'll be more familiar with the parameters and how to access these controllers as you're supporting customers and selling the products. So with that, Vince, you ready?
Let's do it.
All right, sounds good. So let's get started with a review or a walkthrough really quick to get everyone kind of gauged and set on what is available. And if you need to learn more, I've actually posted the links to both of these programs or we'll say set of videos. Training you on all the aspects of set point, process variable, what they are, and it's a real deep dive. We don't have enough time for that today, but the links are actually in the chat. You're more than welcome to all those if you haven't seen them already. You're also welcome to share those with customers. James Lewis, who I don't think is on the call today, did a really good job with walking through and explaining to you in detail why this setting is important and how this affects a process, which ultimately is going to help when James explained it to us in detail, is going to help you understand one, what are you selecting when Vince goes through selecting a controller, and more importantly, where those settings are in the controller. Program 101, we covered deep dive into P&ID control, tuning, inputs, outputs, your basic overview. The links are again in the chat. They're on the unpublished YouTube site. They'll be posted on the SharePoint and available to everyone. They are available to everyone. So I encourage all of you to touch on that. And if you're not familiar with these concepts or ideas I'm going to touch on, definitely reference that for more of a deep dive. Now, set point, I would hope everyone on the call understands what set point is, but that's just the start of all the programming and how the programming affects the controller controls the process. And there's ways to tighten up the process, to improve the process. And there's a lot of steps along the way, one of which is, the process variable. And we explain how that correlates to the set point, how we work through that, and more importantly, how the P&ID loop in the controller, so you got your proportional band, so think of how far, how long, how fast. So, that's where your ramp up time gets calculated and recalculated actually with the auto reset and the timing to avoid overshoot. You think about dialing it into the degree. We can do that if the settings are correct and you know what to look for. And in that video, which is actually the links there at the bottom, we talk about how to look for that and how to walk a customer through. The other reason I focus on the video so much is you can share this with your customer. You can say, hey, look, maybe I'm not entirely understanding it. Maybe you don't have time. You can shoot this to them, let them kind of study it up. They're short 5-10 minute videos that walk through that stuff. From there, it comes to the more standard stuff, like what's your input type, how to set those input types, and we're going to walk through that in a little bit. But there's a couple things that get overlooked that you may not be familiar with or have enough exposure to. And that would be maybe along the lines of an analog signal. It's very, very important in all of these controllers to scale them and how to scale them. And what I mean by scaling is there's a correlation of one, the scaling, like to what decimal point, to how granular you want your control. But there's also this side of the scaling that allows you to limit operator control. It also allows you to correlate, is back to as the example there, say a 4 to 20 milliamp. Well, at 20 milliamps, we're running at the high temp. At 4 milliamps, we're running at the low temp. And that's driving your demand. And that's where we get into your controllers, your contactors, your SCRs, and how the controller interacts with those. And then then your output capability is how you set that. It seems like a lot, but when you walk through it, 1, 2, 3, it starts to become a lot easier to have the conversation with your customer. It's a lot easier to select the right controller and understand what parameters you are looking for. Some of these controllers are more advanced than is needed for your application. Sometimes you need to go with the high dollar controller, but sometimes you don't. And that's where we want to avoid the confusion, know what to look for. And those are the things Vince is going to walk through with us here shortly. You think of stuff like, process high alarm, you set your band alarm. There's even a thing, called sensor break, where say the sensor is not reporting a signal. You can set up a controller to where it continues to operate off the assumption that it's there, off the assumption it's not. There's a lot of really specific settings that are great to have and to control, but if you don't maybe understand how they correlate to a process, it becomes a little difficult to advise or walk a customer through them. So those videos are certainly there for you to walk through. Again, talk about scaling a lot. You'll see that here in the videos, because that's actually, when you go right into the configure mode, that's some of the first settings you're going to see and why that's important and what scale you should be looking for. So you'll have a lot of talk about that. There are other settings in there. I call them gotchas a lot of times. Think of, there's reverse acting versus direct acting. Well, what do those terms mean? Well, actually, reverse acting, you got to think of it as this is your heating cycle. You're heating up, as opposed to a direct acting, which would be more of a cooling cycle. Vince will touch on that and explain that a little further in a minute. The programming 202 or 201 takes a little further dive into those communications and those settings. I welcome all of you to go through those. It's even got, mapping, more about the scaling. There's even configuration software and walkthroughs of how to set up our controllers. It's already available for you. I don't need to bore you with the details today, but I want to make you aware that that is already available, and some of you may not realize that. We talk about analog signals, how to program those, how to, what you're looking for. But again, the scaling is crucial. So the question, everyone gets a call about my process isn't working. What is wrong, right? Well, you think of as examples below, it's a problem with my PC, try restarting it. My phone's screwed up years ago, you just take the battery out. Well, if your controller is not behaving as expected, it might have to do just simply with the scaling of how, and we walk through how to find that scaling, what it is. You may not have to interpret it and understand it right now, because we're not the troubleshooting folks, but you have to have an understanding of it and its capability to know what's going on, because quite frankly, as soon as a customer has a problem, we're the first call they make. It would be good to have a knowledge of that to at least get them comfortable. I mean, ultimately solve their problem, but knowing where to go for support and having an understanding of that only helps your credibility with your customer. And that's what we touch on in those videos, and we walk you through. Inputs, we talk about scaling, how to integrate with the PLC is certainly part of that. And then obviously selection, we're going to go through in a minute with Vince. But your controller specific, that's actually the first thing I generally ask when somebody calls in. What is the controller? And it's not, is it a 4040? It's a 4040 what? So now we understand how many inputs we have, how many outputs we have, and how we can now understand, why is it not behaving as the customer is anticipated. There's a deep dive into control theory about, SSO drive, relays, analog, how you split up the the signal curve, and how that power correlates to the performance of the heater. So I don't worry all with that. All the way to remote set point, which again, guess what? Needs to be scaled. That is in there as well. I know this was just a short touch on all these things. I would hope that all of you have either watched or referenced these. I'm not saying you have to learn them all today. It's good to know it's there. It's good to get a refresher and know what you're doing. Again, helping your credibility with your customer, selecting the proper controller, understanding the programming to a degree. I'm not saying all of us, any of us, have to be experts, but you have to understand, and that's why I touched on this, the language and what we're looking at. So when we do the videos here in a little bit, you'll know what those settings are and whether they're affecting the process and how they're affecting the process. That was my short interim of going through what is available and talk a little bit of the jargon lingo so you'll understand what we're talking about later when we get to the videos. But more importantly, we're going to move on to selecting a controller with Vince. And Vince, I'm going to hand it off to you.
All right, sounds good. Thank you, Derek. And thank you all for joining. I know, I really appreciate everyone on here taking time on a Friday afternoon. And so, my promise to you for taking this time out on Friday afternoon is that I'm not going to be reading a bunch of, specs to you to memorize. What I'm trying to do in this little window here is really go through my thought process of, when I get a call or I'm talking to a customer or, any of you asking, which controller should I go for? These are the steps that I'm making in my mind to try to narrow down the possible selection, of where we want to go. So first things first, you've probably seen this before if you've been in any of my other controller trainings, but this is the thermal loop. The biggest question right off the bat is, are we talking about a temperature controller or a power controller? And a bit to what Derek has said in the past on this meeting here, temperature controller, using a sensor input or a signal input to control, you guessed it, the actual temperature, versus a power controller that's actually sending the electricity to our heaters. So, pretty obvious one right off the bat, but talking about temperature controller or power controller. So from there, for this first part here, we are assuming we are looking for a temperature controller. From there, very next question that you want to ask yourself or the customer is, are we talking about a process controller or a limit controller? And so, you might think, well, they kind of do the same thing, right? Well, not necessarily. With the process controller, trying to take your process variable up to a certain set point and keep it around that, on or around that set point. With the limit control, you tend to have that temperature be at a critical, temperature, whether that's the temperature where your process is really going to start getting, messed up, or there's going to be some damage to the equipment. With the limit controller, as I have highlighted here, there is a latching limit relay. So what that is with our regular process controllers, like a 4040, nothing really shuts down per se when the set point is exceeded. The controller does turn off, but as soon as it gets below that set point again, it's going to turn the equipment back on. With the limit control, if you go above that high limit temperature, it's going to stay off until somebody manually, resets it that says, hey, process is okay. Nothing is damaged or, on fire or something to that effect. We can get the process rolling again. Also, I wanted to show on this screen, there actually is a method behind the controller part numbers. As you can see here, every number for the first 4 digits of those controllers stands for something, at least the newer ones. So you can take a look where there's the DIN size there. That's the very first digit, so you know what size controller you're working with right off the bat. That second digit is, pretty much never anything besides a 0. The third digit there, you can see it's even for our temperature controls, odd for our limit controls. So that might make sense, why a 4040 is temperature control, but a 4050 is a limit control. And then the higher the number, the more advanced it is with more features. So, the 4020 is pretty, or the 6020 is pretty simple, and the 4080 series is a lot more advanced. So I wanted to highlight, arguably the most important section of our catalog for picking a controller. a lot of the time I'll get a call from either customer or one of y'all, and the first thing I'll do is just flip to this page. And really, it can make you seem a lot, especially if you're on the phone, make you seem a lot smarter than you are. Just really just go down this sheet, which we'll touch on, slide after slide here, break it down into a little bit more detail. But I mean, as far as selecting a controller goes, everything pretty much that you need to know is right here on these pages. So I wanted to make you all aware that that exists. So the very first question sets that I go off in my mind when talking about this type of stuff. First one is just, okay, is there already a controller that exists that is doing the job well, and all they're trying to do is replace it with something? If that's the question, or if the question or answer to that is yes, it really does simplify things. You just want to take into account, the size, how it's mounted, number of control loops, and then all the features. We can kind of break it apart, if you want. Try to find the all of the features and everything from the competitors controller, and we can work on that on a case by case basis. So that's kind of the first thing. But assuming this is a a new type of application or opportunity, what I move on then from there is, are there any sort of size requirements? Does it need to be panel facing, where an operator can get to it, right from the front of a panel, or does it need to be in a DIN rail, kind of tucked away? And also just the number of control loops. Does this controller just need to handle controlling, one heater? So the reason why I like to do these questions first, in my mind, physical restraints are really easy to identify and understand without any sort of knowledge of controller theory or anything like that. I mean, if you can eliminate a bunch of options just from this simple stuff like this right off the bat, I mean, you might as well do that. And also too, back to those pages on H4, those are the first 4 rows of the guide. So just knock those out right off the bat. It's going to narrow you down a lot. So the second question set that I think of is all about inputs and outputs. So inputs for our temperature controllers, they are really simple. If your customer is working with any sort of thermocouple or standard RTD, I mean, you can pretty much have extreme confidence that the controller can handle it. I mean, look at all those letters. It's like the whole alphabet pretty much on the inputs for the thermocouple. So, if you hear them say thermocouple RTD, you should feel good right there. If it's an analog input to your controller, you want to be a little bit more careful. You probably will be fine with any of, I guess what I'll say, kind of like the standard 40 series or 20 series, with analog. As you can see on the page here, they have pretty much all of those analog signals covered. The 30-second DIN controller options like the 3204, it's a little bit more limited. So just, be careful. It's always great to double check this page here, but for the most part, I mean, we call it a universal input for a reason. And then for the outputs, I really just use the guide. You want to hear if they're planning to use this controller in conjunction with a contactor for relay output, or an SSR or an SCR for the SSR drive. So your customer should know, or if not, you can give some gentle guidance, on what type of output you'll need there. But inputs and outputs are a strong second place to start to really start to narrow down your options. So question set 3 is basically, all the extra. So whether it's features like a ramp or a soak, or recipes, that's going to change what you want to work with. I have our 80 series controller with the chef's hat here. If you hear the customer say that they need a recipe, you will automatically hop to the 80 series. It is our only controller option that can do something like that. Really what that means, I mean, you can take the word recipe quite literally. You want it to be this temperature for 20 minutes, and then this temperature for half an hour, and then this temperature for 3 hours. So, none of our, I guess, standard, 40 series controllers can do that, but our 80 series has a lot more brain power in there that you can program something way more specific like that. The second, part of this, as far as the extra stuff goes, would be alarm functionality. And so the biggest differentiator there, would be heater break alarms, And, as you can imagine, our 20 series is extremely limited on the alarms and features. 40 series has a bit more. 80 series has a bit more than that. And then finally, we have communication options. A lot of the times for simple applications, you're not going to need to worry about that. But if you do, start to run into some requirements with Modbus, RS-485, TCP, Ethernet, things of that nature, just take a look at that chart, that I keep going back to, and make sure that it's on there. It's really is, as simple as that. So after you go through these 3 question sets, your possible choices as far as controllers that you even can use should be very small. And, my rule of thumb is to choose the simplest one that hits all of the features needed. So, I mean, if you want to do that. So in my opinion, 2 20 series or even, 2 40 series controllers, let's say you wanted to control 2 loops, using 2 of those simple controllers will actually be less expensive and way less complicated than using a 4082. So, I would recommend, if that kind of scenario pops up, unless there's some crazy space restraint that they need just 1 quarter DIN controller, using 2 simpler controllers to achieve an effect of 1 more complicated one is usually the way to go, in my opinion. So that's everything for our temperature controllers, how I kind of go through and narrow it down. Hopping back to the thermal loop here would be, how I go about choosing a power controller, which can be a little bit more, I don't know, nebulous or theoretical, I guess. I don't know. We can get into it, but yeah, we can move forward. So very first question is pretty simple. Are we talking about a contactor or an SSR or an SCR? So, contactor, very simple, on-off control. Want to be longer cycle time so the mechanical components of it don't get worn out. Really simple. And I'll say, just, as far as the CT world goes, if you have an end user and they're, interested in tossing in a contactor or 2 into a quote just so they can just kind of get it and get it done, I think that's a good opportunity to sell these contactors. But if you're working with an OEM and they're needing, 50 or 100 of these a year, probably we're not the best place to get that from, as far as just they're pretty expensive compared to, they can probably get some like Home Depot or something like that even. So if they are not using a contactor, they're almost certainly using an SCR. And that's when you're going to get way more control. PID control is a lot more functional on these types of controllers. The cycle time is way faster. There's no, hard mechanical components that can get worn out. And so yeah, I mean, those are really 90% of the time you're going to run into either a contactor or an SCR. So that's the first question. And then, so the first kind of real question then, after you get to, either a contactor or an SCR, for the purposes of this presentation, we're going to kind of dive deeper into selecting an SCR. Question 1 from there is, how many phases and legs? So, this basically will just match up with whatever the actual heater is as far as the phases. It's either a single phase heating element or, a flange heater with just 1 heating element on there, or it's 3 phases. So that's, quite a standard thing for us. So you just want to make sure you know what's going on there. Second thing is, you want to know, if it's 3 phases, are they okay with just having 2 leg control, which is less expensive, and really does almost the exact same thing as 3 legs, or do they absolutely need 3 legs because they need phase angle firing for some sort of true soft start? And those concepts are explained a lot more in James Lewis's previous videos. So I'm not going to take time to dive into all that. But, really simple question: how many, what phase we're working in, and if it's 3 phase, how many legs? Question 2 is the firing method. This one is a little bit more complicated. So you're going to, once you've determined the amount of the phase and the legs, you want to make sure if your customer is okay with a 0 cross firing method, whether it's time proportional or dot fired. And again, using that same chart for the SSRs, you can go through and look at that chart and see exactly what's on there. So for just as an explanation, the 0 cross that covers the second to last row there of proportional. And, for simplicity's sake on this chart, proportional means time proportional. And if it's a dot fire, they'll just have it in the parentheses there. Something else I will note is that for the CTF, the second column there, we have on there that it is phase angle fired. That is only the case if you are using this in single phase. You can use multiple CTFs to get 3-phase 2-leg or 3-phase 3-leg operation. If you do it that way, it will actually only be able to do a 0 cross firing method. It just gets really complicated with the timing if you have 3 separate controllers trying to do phase angle, just as a little FYI there. Yeah, and then so phase angle, it generates a lot more electrical noise, but for certain applications, it's necessary. And most of the time, your customer, actually almost all the time really, if your customer needs phase angle, I mean, they're going to know that and they're going to tell you. So 0 cross is fine for the vast majority of applications, unless stated. Okay, question 3 is also really simple. Mounting, line voltage, and current. So the mounting, most of the time, well, I shouldn't say most, but a lot of the time, as far as just how a panel is constructed, these SCRs and SSRs are just mounted to the rear of the panel. There are also, for some smaller SCRs, DIN rail mounted. That's usually not a make or break to any customer unless we're replacing an existing piece of equipment, but something to keep in mind. And then the line voltage and current load are really simple. Really just want to make sure that whatever you choose there matches up with the heater demands that they're using to, that they're controlling. That's really all it is to it. And then question 4 is going to be the inputs. If you remember when I was talking about the temperature controllers, when we get to inputs, life is really easy. It's almost the opposite for the SCR controllers. There's a lot more variation, and you want to make sure that you choose the right input. And yeah. So what I did here, the little snippet on the right, I'm not going to read all that right now, but James Lewis actually sent out a CT newsletter maybe a year or two now, or probably 2 years ago, and I really, really liked this snippet that he included on there. So if you have the time, I would, read this once we send it out. But this is really kind of a long way, a good explanation of a way to say that there's a difference between SSR drive and analog inputs. SSR drive has the pickup and dropout voltages. So those numbers, if you're talking to a customer, those numbers on the on that don't need to match up exactly. You'll see on a lot of our literature, we use 5 to 32 VDC. And that's just kind of what we've set as a company standard on our literature. The customer's numbers might be a little bit different, but it'll still be okay. For the analog control, we talked about 0 to 20 milliamps, 4 to 20 milliamps, all that kind of stuff. You want to make sure that if a customer tells you, any sort of analog range, that it does match exactly. So again, with the SSR drive, numbers don't need to match exactly, but for proportional analog type of stuff, they do. And finally, same last question again, features, alarms, communication. Didn't want to go through all of our options. It's kind of a lot, but just as kind of a general sense of how I look at our controller lineup. We have our luxury models of the C series, the CFW, CTF, C4. I mean, those things have just so many features, communication options, alarms. I mean, there's even, internal thermocouples on the SCR itself that make sure that the SCR itself doesn't overheat. Then we have kind of our mid-grade, used a lot with OEMs, or would be our Max Packs and our Mini Max. They have way less communication options as a C series, but they do have a good amount of alarms and some other features that'll come in handy. Plus, they're just compact and can handle some really high amperages as well. And then finally, we have the economy series, which is our CS series and SSR series of SSRs. They're really simple. The CS series has some simple alarms, but nothing groundbreaking by any means. If you're working with higher volumes, really just need something simple just to turn on and off a heater. That's where you're going to want to look. And to break down even further, so our SSR series controllers, they're often referred in the field as hockey pucks, and they are very, very cost competitive. There's companies that sell these, by the thousands, so it can be kind of tough. And if we don't have an SSR model that you're looking for that's stocked, the lead times can be pretty crazy, especially nowadays. These come out of Italy, so I've seen some lead times for non-stocked SSRs of this model, that are in the 100 plus business days. So if you're working with, an OEM where it's going to be some consistent ordering, I would strongly recommend the CS series. We have a much better relationship, to be quite frank, with the vendor for those series. It's also cost competitive. The lead times for non-stocked units are still, in the 20 to 30 business day type of range. And honestly, if it's an OEM and the opportunity is big enough, we can absolutely look into stocking more of these too for an OEM. So just a little pointer there when you're out in the field. So yeah, I mean that's how I do it. That's really the steps that I take to narrow down. I know the controller section of our catalog can be very daunting. So I wanted to take 15 minutes really just to not go over specs per se, but just really a thought process that's going to help out with making sure that we move to a appropriate recommendation for a customer.
All right, thanks, Vince. Yeah, as you mentioned too, we do have some training, more deeper dives into the model numbers and stuff like that that are available.